Hi, this is Eva for Once Upon a Timeline, and today we're going to discuss new weird phenomena of lightning, including behaviors and types. Okay, I got this idea from watching Mandela Affected's live stream earlier, where he photographed and videoed some lightning in his area, and he noticed that it looked different. And I agree with him. Now, I have seen some changes in online images of lightning, but he noticed some details which he did not really specifically say. But I'm pretty sure that he was talking about this issue here. Now, I found this GIF, and way back when I was a kid, everybody assumed that lightning came from the clouds down to the ground. But I had researched lightning quite a bit, even in my teens, and the scholarly articles all said that lightning came from the ground up. And nobody really believed me, but I would show them the articles, and they were like, yeah, and then they were kind of skeptical. And so that whole thing is kind of a weird thing, and I've been hesitant to even bring that up because I figured, who knows even now with the reality. And nobody even believed me back then when I had the articles to back me. Okay, so about a year or so ago, I researched lightning a bit more. And at that time, they were saying it comes from the sky to the ground almost always, but rarely it would come from the ground up. So that was an ME for me, but I figured it probably wasn't for a lot of people who did not research lightning or came from a different timeline. Okay, so now I'm looking at Mandela Affected's video of his lightning where he lives, and we don't see a lot of lightning here, so I can't really observe it very often. But what I saw was that the lightning now persists in the sky a lot longer. It's more flickery. You can see it. Used to be it was just like psh, and if you weren't looking right there at that second, you just had that millisecond to see it, and that was it. But now it flickers along the same track. Also, some people commented on his video that there's a flash before the lightning that you see. So you see a white flash, and then you see the bolt. And I had not picked up on that, but I agree that used to be that the bolt and the flash were at the same time, but now there is a flash earlier. I'm the one who kind of mentioned, at least so far, about the flickering. I don't think anybody's seen that yet, but I suspect that that's what Mandela Effect is also noticing on that video. Okay, so I looked this up, and here we see kind of what we've got in the current timeline. This is interesting. This GIF shows kind of a slow propagating lightning. Now, my old timeline, it was just psh, lightning, and that was it. But there's the slow propagating lightning coming from above, and it is a little bit thinner. I don't remember lightning moving like that at all. And the storyline now seems to be that this lightning is kind of feeling out the area, and then you'll see that one of the lines that this original lightning took is then backed up by a reverse bolt that comes back up, and it's thicker. And I did see something about 8 months ago where they're saying it's newly discovered that some lightning is thicker. I think they were calling it like super lightning or something like that, and I can't find that now. But this GIF kind of explains it. The enlightening image below is of a lightning strike slowed down. It can be seen that the most intense flash produced from the lightning occurs in the direction from the ground up. Why does this final ground up strike occur, and why is it so much brighter and faster than the initial part heading towards the ground? And the answer is those initial streamers are looking for a path of least resistance. When they find it, the stroke comes up from the ground. So now we've got both coming down and coming up. Their behavior is different. This one's slower, more propagating, more sideways. And then the final one is fast, more like my old lightning, and thicker, which is not like my old lightning, and more intense. So we've got these two kinds now, it looks like, is what they're coming up with. And there's been a lot of changes in lightning. Here's kind of an explanation of the spiel now of what they're saying, that they're kind of vague on this, but it's like they have a word for these kind of seeker tendrils. And then there's like tendrils coming up from below that are kind of trying to figure out the path. So they're saying that once the path is connected, here's what's neat. They say the path connects and the lightning starts there and goes down. And then it goes up one more batch up there. So this is different. They're saying the lightning goes like this, and then it goes like this. And then, so this is confusing because it kind of contradicts what another one was saying. But they're saying that that's how the lightning propagates, not in a straight bolt. So the whole thing, I don't know. There's a lot of storylines now. None of them match my old. Look at how thick that bolt is, though. I mean, lightning was never that thick before. Just never. Now, these are these little tendrils they're saying are coming up and hunting for path of least resistance. They're calling this a failed one, but you can see it. You can see it. So check out this video, How Lightning Works, by Adam Suydam. Suydam. There's not many views on it, but it is interesting. Let's see. I think that was most of it. Okay, so another thing I just want to point out, lightning is just so much more. It looks like a tree now. This is the ground up lightning. Used to see the lightning was just simpler. It didn't look like a tree. You would just see one bolt, one quick bolt. You couldn't tell if it was coming from the ground up or the clouds down because there wasn't much branching. But now it looks like this tree. And another thing I've read, there's a lot of them that are showing it thicker at the bottom and a different color at the bottom, more intense at the bottom. So interesting stuff here. Turn off the videos, but see how it flickers along now? It really kind of propagates differently than it used to. So yeah, a lot of changes. Look at that one. They weren't like trees before. And they didn't propagate so far. They didn't flicker so long. You have a lot longer time to see it now. It's a lot thicker. There's also been a lot of other changes in the lightning. One thing that I was reading about just recently that on my live stream someone brought to my attention, tsunami lightning. You might have heard of earthquake lights. In my old timeline, it was a rumor that was not taken seriously, that weird light phenomena would happen before an earthquake. Well, apparently that's now accepted. There are pictures of it. But also, they're saying that lightning, not just any old lights, but lightning seems to be associated with earthquakes and tsunamis. One of the intriguing events accompanying large tsunamis, especially those that strike the Pacific coast of Japan, is the luminous phenomena. Many historical Japanese documents have described how fireballs or pillars of fire seem to come out of the sea when tsunami approaches. And sometimes they're saying it's lightning. I have not heard of this tsunami light effects. I've only heard of earthquake light effects. So apparently now, the tsunami happens later after the quake. So this is kind of a expansion of the whole earthquake lights thing. All right, now here's another one that somebody brought up in my last live stream that really surprised me because I had no freaking clue about the colors of lightning. That is totally new for me. But here we have this article. As I'm sure you're aware, no, I was not, lightning bolts can display a wide variety of colors ranging from lilac, white, and blue to even more exotic colors like yellow, orange, and green. There are many causes for this wide variety of colors. This ranges from temperature of the lightning to atmospheric and environmental conditions. So it looks like they're gearing up here to have multicolored lightning because the temperature of the lightning is supposedly different at different areas along the bolt. And now they're saying that it can be a different color by temperature. So I think we're really gearing up to see more colorful lightning. Lilac or purple tinted lightning is usually the most commonly observed color. You know what? I just remember white. And when I was researching this, some articles say white is the most common, but here purple is the most common. It is often caused by precipitation, so the observation of it most likely means that the thunderstorm generating it will be high precipitation storm. Lilac lightning is also rumored to produce louder thunder, though this has been disputed. I've never heard of that. Colored lightning having to do with the loudness of the thunder. This is like psh, mind blown. Blue lightning bolts tend to be the hottest lightning bolts to occur on Earth. They are also some of the more commonly observed colors after lilac. They may be caused by small amounts of dust in the atmosphere. This is because these dust particles scatter the light coming from the lightning in a similar way to how molecules in the atmosphere scatter the sun's light, making the sky also look blue. White lightning, most common. The air must be free of pollutants and dust, which can scatter and refract light. Well, white lightning was the only lightning, so I want to say it's most common. I'm not sure now. You guys, when you see lightning storms, see if you can figure out what colors they are, because we don't see much lightning here, and so it's not easy for me to check on the ground. Okay, so white lightning, you're seeing lightning with very little interference from the atmosphere. White lightning is also some of the hottest that occurs on Earth after blue lightning. Yellow lightning bolts are much more uncommon and tend to be cooler than blue, white, and lilac. They are also tend to be indicative of dry thunderstorms. So the presence of yellow tinted lightning could mean that an approaching thunderstorm is a low precipitation storm. We'll get into a bit about dry lightning. That one's kind of there's some kind of weird lightnings out there, but basically, I think I've covered it in the past, is that nowadays you can get lightning from fires, and you can get lightnings from volcanoes, and so they call that dry lightning now, where it just comes from this ground up phenomena of smoke, and that's pretty new for me. I saw the volcano one maybe 6 months ago, but the fire one is very new for me. Other colors of lightning have also been reported. Orange and red have been observed, and these bolts tend to be some of the coldest lightning. These colors also tend to be observed near the base of the lightning. Okay, so we're getting already here different colors along the length of the lightning. Green tinted lightning is also occasionally seen, and this may be caused by lightning heating up certain gases in the air, giving it a greenish tint. Now, in another location I also saw, they're saying green lightning can happen when lightning hits a transformer. So anyway, lots of stories floating around about the colors. They're a little bit non-cohesive right now. This is another storyline. 3 most common colors from white are blue, yellow, and violet. The color of the bolt depends on how hot it is. The hotter the lightning, the closer the color will be to the end of the spectrum. Now, this is a different storyline than it has to do with atmospheric conditions. Now they're saying it's the hotness of the lightning determines what part of the spectrum it's on. The color spectrum in this case starts with infrared, which is red, and the coolest up to ultraviolet, which appears to be violet and is the hottest. Lightning can take on a range of colors. Typically, blue lightning indicates presence of hail. Red lightning indicates presence of rain within a cloud. I don't remember seeing red lightning ever, and it usually rains with lightning storms. So yellow or orange lightning occurs when there is a large concentration of dust. White lightning is a sign of low humidity. Okay, the other article was saying it was a sign of clear air. What is the color of lightning that most often ignites? White is the color that most often ignites forest fires. This is all just, it's totally weird. I've never heard any of this stuff. And I just researched lightning like 6 months ago. There was nothing. All right. 6 months ago, I did see this. In my old timeline, there were rumors of weird sky phenomena above, like in the upper atmosphere, and one of them was like sprites and elves. They were just rumors. There were no images of them. About 6 months ago, I noticed that these phenomena had become accepted, and there were old images of them, and they were no longer disputed. One of those things was elves, and these are the shapes. They go in that way high upper atmosphere, and they call it a form of lightning, but it's just weird looking. They're way up there. I noticed that these have really kind of intensified since last time I looked at it. They have only been studied since 1989. Well, I've never even heard of them in '89. It's very recent to me that they're accepted. But these are really weird looking. There's better images of them all the time. Another one are these elves, red sprites, blue elves, I think they call them. They look kind of similar. The elves also are sometimes associated with this donut pattern of lighting phenomena that current timeline is not well understood but is accepted. Here's an image of the donut light phenomena. So those elves and sprites are now accepted. Blue jets is another one, although they're looking kind of purple here. They're kind of similar. They're just a little bit different shapes to them. They're all upper atmosphere. Okay, another one, ball lightning. I realized on my chat, on my live stream, that some people weren't familiar with ball lightning. That is from my old timeline, but it was just, again, a rumor. There was no evidence of it, and most people were skeptical of it. But basically, I always thought it was weird that they would call it lightning, because it would be a ball of light would be observed. It didn't burn anything, and it would kind of float around like a balloon and then appear and disappear. And they called it ball lightning. I never knew why they called it lightning, because it didn't act like lightning. But here they actually have the video of a ball lightning now. It's not the world's best video, but this ball here is supposed to be ball lightning. I'm just going to play it a bit because it's not the easiest to look at video. Okay, here's some more ball lightning that they supposedly caught images of. Okay, the last weird thing for today is dark lightning. I heard about this about 6 months ago, but it seems to be a little more established now. They're saying that sometimes there's radiation pulses from this clouds like lightning, but they're invisible, and they contain high doses of gamma and X-rays. And there was some concern that planes might be hit by these. Now, they won't hurt you the same way that regular lightning would hit you, but you would get a very high dose of radiation. So it would be like a concern for cancer and stuff like that. They're saying you could get like a lifetime dose of radiation if you get hit by one of these, even though they're invisible. Sometimes its flashes are invisible, just sudden pulses of unexpectedly powerful radiation. So this is getting more accepted now. I don't know, the whole storyline about how the lightning connects with the earth and the paths it travels. There's a bunch of stories all over now, but it's not like it used to be. The lightning is acting different. Try to keep an eye on the storylines for how the lightning connects now with the earth and what's coming up. There's stuff coming up. There's streamers coming up. There's streamings coming down. It's getting really complicated, and there's not like really one storyline I can find. So I think that's rapidly going to change, and I also think that we're going to start to get some pretty colored lightning here in the next batch of shifts. So this is Eva signing off for Once Upon a Timeline.